I can get my hands on some of those darling seedlings.
Yep.
Planted pretty close to a Chinquapin that's actually making nuts. Do you suppose those nuts would be able to have a gene that would keep on going?
Can we hybridize with Chinquapins is the question, basically, right?
Yeah.
I don't know too much about hybridization between American Chestnut and Chinquapin. Does anyone else have more expertise?
We got the disease
Yep.
from the chestnuts, so
Yep.
them people can be kinfolk.
The fungus doesn't distinguish between the trees, but I don't. If the trees can hybridize, then they should be able to inherit the gene. More likely, since you're striving for 100% pure Ozark Chinquapin, it would probably be, ideal to just basically start over and start transforming an Ozark Chinquapin rather than trying to hybridize. To get to the part of your question, could you plant them? That turns into a USDA regulatory question, and we'd have to, start a new location on the permit, and it's possible. It's complicated, but we're not allowed to distribute the transgenic chestnuts yet. So far, we can't let you play with them, but hopefully in a few years we are headed that direction. Yeah.
You said that you use the bacterium to get the gene into the embryos.
Yep.
How do you identify which cells actually have the gene, and how do you get rid of the ones that don't?
Yeah, good question. How do I identify which cells, early in the process, how do I identify which cells have picked up the gene? The picture I showed you with the glowing green cells, we used a separate gene, or a marker gene, called GFP, green fluorescent protein. And that's really easy to see, because under UV light, it fluoresces. You see which ones look green. They don't look any different under white light, but the fact that it's GFP would make it a lot more complicated with the regulatory system. So we've actually moved away from using that visual marker. Nobody wants trees that glow green, even though they don't actually glow unless you shine a UV light on them. It's scary, and GFP hasn't been deregulated in anything else so far. So we're moving away from that system. We're just using a selectable marker, it's called, where it's a gene that allows specific antibiotic resistance. So in addition to the OXO, we put in this gene, it's called NPT2 if any of you care. But basically, after we put the genes in, we coat the embryos in an antibiotic that kills off any tissue that doesn't have the gene. So we slowly kill off any tissue that doesn't have the gene. Those few cells that have picked up the gene can multiply and propagate themselves until they're into embryos, at which point we just grow those and we don't need the antibiotic anymore. Does that answer your question?
Yes, it does.
Okay. Yep.
So does that OXO appear in the nuts? Is it expressed in the nuts?
Yes. The question is, where is the gene expressed? And the trees that we're testing right now, the newest trees, let me back up. Expression or patterns of expression would be directed by what's called a promoter. It's kind of a switch within the DNA that controls how much a gene is expressed and where it's expressed and when it's expressed. The promoter that we're using is called a constitutive promoter, which means that the gene is expressed pretty much all the time at high levels. And so that means in basically all tissues. We see in the leaves when we do the leaf assays, in addition to stems. So yes, it would be expressed in the nut tissue also.
And so with that, have you seen how that compares to like all your other fruits and vegetables that show that express that gene?
That have the OXO. We haven't compared it directly to banana because I don't know what what kind of comparisons that would mean. We've been comparing it to non-transgenic American chestnuts, and I showed you those pie charts with the metabolite analyses. I think that was from stem, if I remember right. That the tissue we tested. We've also tested nut tissue with the metabolites, and that'll be a big part of the regulatory review also, especially with the FDA, who's concerned about food. They want to make sure we're not affecting the nutrition of the nuts or anything else. So yes, that will certainly be an increasing part. As soon as we can produce enough nuts that we don't want to plant every single one we want to produce, as soon as we can produce enough that we're willing to send a few away for nutrition analysis, that's a very high priority for us and for the FDA.
I've got a couple questions for you, Andy. Just this is a little bit off the side, but the aquatic insects, in your opinion, what is it about chestnut leaves that their population grows larger on aquatic insects? I mean, what is going on in that aspect of it?
The question is why the insects prefer chestnut?
Yeah, over like
Basically,
the more
over
acidic,
the
is
oak
it something to do with tannic acid in it?
It
or-
could be a chemical composition. My first thought is that these insects are native to streams where American chestnuts were common for, their recent history, their evolutionary history. And so since they basically evolved with American chestnuts, that might be their just historic evolutionary preference. That's how they developed over the past millennia.
I know ash trees have a neutral pH of 7 compared to like the oaks and hickories are more acidic, like a 4.5 or 5.5. So I just wondered if I was just curious, that
There
it goes
might
several
be
ways. I mean,
nutritional or pH chemical differences. I don't know. I don't even know if that was tested for these insects.
the other question I had too is I'm just playing the devil's advocate here, so I'm just tossing this out. All the trees that y'all had, when you first grow them, it looks like you said a bent branch, and you had to coppice that, actually cut it off. So then with that root system, you had that straight, more chestnut-looking growth pattern, tree pattern. If those were not coppiced or cut off, what would be the growth pattern? Have y'all looked at that to see what it would look like if it weren't cut off?
Yeah, questions about growth patterns of the tissue culture chestnuts. And a couple of things. I mean, if a tree starts growing with a crook and then rights itself, the crook is never going to come out. After that tree is kind of solidified into that form, you can't just bend it back or correct it, or it's not going to correct itself. So if the crook or form is such that it's a weak tree and would likely break off in a storm at some point in the future or whatever, then it might, shoots might grow back for that. As far as correcting the growth, coppicing or coppicing is certainly the cleanest, it makes a lot of sense to us that a new shoot is just going to be straight. But also what we've seen is just starting the trees when they're in the greenhouse, while they're still soft before they've kind of solidified into any form. If we stake them up quite tightly, then we can convince them to grow as leaders, as main stems, instead of as branches. The first few times we tested that, we were concerned about strangling the trees. We don't want to wire them up to a stake too tight because that can cause problems also. And what we saw is, okay, if we tie it gently, then it grows out of the tie and then just leans over again. New grad student who worked in a nursery is just a lot more aggressive with his staking, and he actually takes pipe cleaners and winds them around to just secure these trees to a little bamboo stake. And if we can keep that even for a few months during that initial critical form development period, what we've seen is that they continue a straight growth. So of course that's just higher maintenance. You need to make sure that that tie doesn't stay on too long or loosen it up as you go along. But we have seen at least many instances where we've been able to correct that by physically tying them up.